Welcome to my lecture on comparing means ANOVA. What is ANOVA? Just like the t-test, ANOVA is a test of comparing means. The only difference between t-test and ANOVA is that in a t-test you can only compare two sample means. But in ANOVA you can compare more than two means. ANOVA is based on the F-test statistics, or so-called F-ratio. F-test tells us whether there is an overall effect of groups or experimental conditions. One thing F-test does not tell us, however, is the details about how conditions may be different from each other. Let us first take a hypothetical example. Couples get to know each other in various ways. According to the statistics, 19% of couples meet online. 17% of couples meet through a friend. And 15% of couples meet in a bar or in a restaurant. Let's say we want to find out which couple is feeling the happiest after some years later. The rationale for the F-test or ANOVA is the same as the rationale for the t-test. To test whether our hypothesis is a good explanation of the data we have observed, we need to compare the explained variability against the unexplained variability by the model. Let me shortly explain how explained and unexplained variability for F-tests are calculated. First, there are three groups: the couples who met in a bar, the couples who met through friends, and the couples who met online. The vertical numbers show how happy couples feel after a few years of being in a relationship. The grand mean is the average happiness scores of all couples regardless of how they met. The group mean is the average happiness scores of couples in each group. There are three group means: the mean for couples who met at a bar, the mean for couples who met through friends, and the mean for couples who met online. To calculate the explained variability, we estimate the differences between each group mean and the grand mean. We square those differences and add them up. This is basically the effect of the group on couples' happiness scores. To calculate the unexplained variability, we now estimate the differences between each group mean and each score from every couple within the group. We square those differences and add them up. This is basically the error in a model that is unexplained by the group factor. By the way, why do we always square the differences? This is because when we deduct one mean from the other to calculate the differences between two means, some differences are negative and others are positive. Squaring the differences makes everything positive, which helps us interpret the numbers easier. Similar to t-test, F-test is calculated by explained variability divided by the unexplained variability by the model. Explained variability is the average sum of squares of the model that was calculated based on the differences between the grand mean and the group means. Unexplained variability is the average sum of squares of the residual or the errors, which was calculated based on the differences between the group means and each scores. Let me now show you how we can run ANOVA using R. As you can see, this data set has 10 pairs who met in a bar, 10 pairs who met through friends, and 10 pairs who met online. For each pair, we asked how happy they are in their relationship. We want to test ANOVA to see whether these three groups of pairs differ in their happiness scores. To run ANOVA, you can go to Statistics, Means, and click One-Way ANOVA. Here, you should pick a grouping variable and a dependent variable. In our case, is a happiness score. You should also click Pairwise Comparisons of Means, which basically show you the results of t-tests for each pair. You can click OK. Here's the results of ANOVA. First, you see the results of F statistics. You have an F value and a p-value for F. If the p-value is bigger than 0.05, that means there was no effect of group on happiness scores. If this value was smaller than 0.05, that would have mean that the group has an effect on happiness scores. In this case, the p-value is bigger than 0.05, so the groups did not differ in their happiness scores in our data. Underneath, you also see the means and standard deviations for each group, also a sample size, n. And below that, you also see the results of t-tests, which are multiple comparisons of means. There you can see the t-value and a p-value for each pair of groups. For example, a couple who met via friends and a couple who met in a bar, and how they differ in their happiness scores. As you can see, the p-value is bigger than 0.05, so we can conclude that the couples who met through friends and who met in a bar did not differ in their happiness scores. That was it for today's lecture. Thank you for listening and see you next time.